Welcome to Brain Vision.
We have this disc that has a weight of 5 pounds resting on a belt, and this belt is moving at a speed v. And due to the kinetic frictional force, it's exerting a force in the rightwards direction. So we want to determine what is the time interval required for it to reach a constant speed, a constant angular velocity. So to do this, so the concept that we're using here is the impulse momentum theorem, which essentially states that if you have a change in angular momentum, there needs to be some couple times a change in time, and this is an impulse that will cause that change in momentum. In this case, because we're starting from rest, we can just look at the final angular momentum of the system. So m times the change in time is equal to I omega final. M, the moment, is going to be the kinetic frictional force, Fk, times the lever arm, which is in this case the radius. So we have Fk times r times change in t is equal to, in this case, since we have a uniform solid disk, the moment of inertia is given by 1/2 mr squared. We also know that omega is equal to v over r. Since the final speed of the disk is going to match the speed of the belt, which is 50 feet per second, we know that this is equal to v over r. We're not going to actually solve that yet. We're just going to wait till the end. So these r's are going to drop out right away. We can see that happens. And now we're going to look at this system. So we know that the Fy, the net force in the y direction, is equal to 0. So it's also equal to Fn, as you can see from the diagram, Fn minus mg. That means that Fn is equal to mg. We know that the kinetic frictional force is given to us by Fn times the coefficient of kinetic friction, which means that it is mg times the coefficient of kinetic friction. Now that we know that, we can say that mg times the coefficient of kinetic friction is equal to t times 1/2 mv. We also know that the m's are going to cancel out, so now we simply solve the following. We just plug in to the following equation to get our time interval. It is v over 2g times the coefficient of kinetic friction. So let's plug in our values. V is equal to 50. G is equal to 32.2 feet per second squared. And our coefficient of kinetic friction is 0.20. So that gives us 3.88 seconds.